There are 5 ways to prove triangles congruent that we're going to be using in this chapter. And this video, I'm going to try to get them all into this one video, so it might be a little bit long, but hopefully it will only be one video for day 2 notes. The 5 ways are side, 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 angle, side, angle, side, angle, 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 side, and HL. And you might feel like you will forget all those weird letter combinations, but as we practice them, you'll get them down and it will be pretty easy to use them. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent is the side, side, side congruence postulate. And so we're being asked to write a congruent statement here. Remember that the congruent statement is you naming the 2 figures congruent to each other, and the order matters and will make this a true statement, or it could be incorrect if I do this wrong. So the first one you name in any order you want. So I said A, B, C, going around this triangle this way. Now the triangles don't have to be oriented the same way when they're drawn on the picture. They can be flip-flop, they could be overlapping, and so you have to be really careful. And with side, 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 it's kind of the hardest one to do. So A was between the 3 marked side and the 1 marked side. So go find the one that's between the 3 marks and the 1 mark, and that would be angle R. So angle R must come first. Then I went from A across the 1 marked side to B. So go across the 1 marked side, and then you're at S. Then I crossed the 2 marked side to end at T, and now I know that they're named in the corresponding order. It was easy here because the pictures are oriented the same way, but sometimes it's harder than others to do that. Here is a proof using side, side, side to demonstrate. They've given us that AB is congruent to CB, and they've already marked it. They've given that D is the midpoint of AC. I like to look at my picture and I like to think about what that means. What that means is that each of these sides is going to be congruent. We will be using that in the proof, but I kind of like to look at my picture and strategize before I jump into the proof. Now I'm out of my given statements and I just look at the picture for a moment. These triangles are touching. When your triangles are touching, a lot of the time you have a shared side or vertical angles that could happen. Sometimes you've got parallel lines that will lead to angle pairs. These 2 triangles are sharing the side DB in the middle here. So I'm going to mark that with 3 marks because it's not the same as the 1 or the 2. And that is the 3rd side. Now notice that all 3 sides of the triangles are marked, so we know that we're going to use side, side, side as our reason. And now let's go to the proof. So AB congruent to CB was given. D is the midpoint, that was given. AD congruent to CD, that comes from this using that midpoint definition of midpoint. BD congruent to BD, that's the shared side, that's that reflexive property. Reflexive prop, congruence here because it's congruence. And now we can say that the triangles are congruent by the side, side, side congruence postulate. And that's the proof for that one. There's our side, side, side sample. The next one is side, angle, side. If 2 sides and the included angle, and that word there, included, is very important to know what that means. Since it's side, angle, side with the word angle in the middle and the letter A is in the middle there, that means that that angle is going to be surrounded by the sides. See how angle R is surrounded by the marked sides? They both touch it. And angle U is the same way. Both of those sides are touching angle U, so the angle is called an included angle because it's between those 2 sides. And that's how you know that you're using side, angle, side, in this problem, that included angle there. That's how you know the order to write the letters in. The angle is in the middle, so you put A in the middle. Write the appropriate congruent statement. Again, this is naming these congruent triangles. Just name the first one however. And a lot of the time we give you the first one because we want you to, it's easier to grade that way, So I named RST, starting at R, going around. Angle R was marked. That's why I started there. It makes it easier for me. That means I'm going to start at angle U in the other one. I went from R across the side with 2 markings. So I need to go from U across the side with 2 markings to V and then to W. Again, remember that these are easy ones because the picture is oriented the same way, so it kind of just looks like it's really easy to do. But when the pictures are mixed around and overlapping and flip-flopped and everything, it gets difficult. So be very careful. Like I said, I started at R because the angle is marked the same. That means that U is the same as it. Then I cross the side with 2 marks, cross the side with 2 marks, and then cross the side with no marking. So I use those clues in the picture to help me match my corresponding parts. Here's going to be a proof, and with these notes we kind of know this one's going to be a side angle side proof just to demonstrate how you might use it. It says JN congruent to LN, and they've already marked that in the picture here. So again, I like to look at the picture, make my plan before I go to my proof. KN is congruent to MN, and they've marked it. These triangles are touching, but they don't share a side like the previous ones. These have vertical angles in the middle. I like to call this the bow tie picture. When it looks like a bow tie, you've got vertical angles that you're going to have that you can use. So now that I've marked my angles in the middle congruent, I think about my strategy. I have 2 sides and the angle in the middle, so I do know that I'm going to use side angle side to prove these triangles congruent. Now let's fill in. JN is congruent to LN. That's given. KN was congruent to MN. That's given as well. They've listed those as being both the first statement as given. Then they're saying that 1 is congruent to 2, and I had said that those were because they're vertical angles, and we know that vertical angles are congruent. Again, if you do not put congruent here, you will not get credit. You can also put vertical angles postulate. Those are the only 2 things I will accept. If you just put vertical angles, you will get no credit. Be very careful. Then on line 3, it names the congruent triangles, and you use this order if you're having to do that yourself. They've got it in the proof statement right here. And we had said it's because side angles side, because the angle is between those 2 sides. It's surrounded by them. So we're going to use side angle side congruence postulate. Again, I think this one's postulate. Yes. Side angle side congruence postulate. Now, I'm worried this is going to be too long, so I'm going to stop it and do the other 3 on the next video.